Okay, now let's talk about bit streaming and basically how what the term streaming is, what types of streaming exists, and why, in a sense, it's called bit streaming. Why is the term bit streaming so popular here? Okay, again, the reason that I was studying bit streaming is because now we're starting to discover and analyze different applications of the internet that we know of today. And one of the applications we saw in the previous lecture was cloud computing. Another one was your World Wide Web. So the most commonly used application is the World Wide Web. But now, considering how internet has become, basically become very easily accessible to a lot of users on the world, on our planet, and how internet has offered a lot higher bandwidths at lower rates. So it's basically easy for a lot of users to have access to a high-speed internet connection. This is when the concept of streaming has become increasingly popular. Now, what does streaming mean in a sense? What does the term streaming mean? Let's talk about streaming in the terms of videos. If video streaming is considered here, basically video streaming means that I'm accessing a video that is not being played back from my hard disk. So what that means is that if I have downloaded, say, if I have downloaded a video, that means that video from the internet has ended up on my hard disk. It's completely, in its entirety, it is located on my hard disk. Now, whenever I play back that video, the source of information for that video, the playback, is my hard disk. And that is not streaming. On the other hand, if I play back that video directly from the website link, such as we do it on YouTube, in YouTube, you are streaming. YouTube is a streaming service provider. Now, if I'm playing back a video directly from this website on its own, from the web server on its own, that is streaming. So what that means is that instead of the source of my video being my hard disk, it is now my server. Even as we speak right now, the video that you're watching on YouTube is being streamed to you. So the source of the video is not your hard disk, but the source of the video is a YouTube server. So this is essentially the term, the meaning of streaming. So the data is not downloaded. The source of the data is not your hard disk, but in fact, the source of the data is the server, and you're accessing that data through your internet connection. And depending on the active internet connection and the data transfer rates that your internet connection provides, there will be a slow or fast streaming based on those factors, of course. So that's another thing, but you are basically accessing data through an internet connection, and the source of the data is not your computer. That source of the video is not your computer, but it is a server somewhere. Okay. Now, but why is the term bit streaming used? Essentially, it's confusing. Why the term bit? When we have understood that data is supposed to be stored in the form of bytes, we learned very early on in our career that in computer sciences that the basic unit for data storage is byte, and byte is not it's not a lot of data. So that's why we need multiple bytes. We need KB bytes, maybe bytes, KB bytes, TB bytes of data. But the basic unit of data storage is a byte. So wherever in a computer or in a digital device data is stored, it will be stored in the form of bytes. But when it comes to streaming, why is the term bit streaming used? Why not referred to as byte streaming? Well, bit streaming is used because, of course, when I'm transferring data over the internet communication link, I will definitely have to use some sort of compression to make the size smaller. And if I'm compressing data 1 byte at a time, which usually that's the case, I'm compressing bytes of data. Now, if I'm compressing data 1 byte at a time, the size of 1 byte will be reduced to a few bits. So that's why after compressing, when I I prepare the data for data transfer, the data after compression of a byte of data becomes only a few bits are left behind. So that's why data transfer is handled, especially data transfer over streaming services, is handled with respect to bits per second, because I'm applying compression and bytes of a byte of data when compressed becomes into a few bits of data. Okay. Now, as you can see that even your internet speed, bit rate, the number of bits transfer per second, megabits per second, gigabits per second, that too is measured in bits per second, because that too is also a data transfer unit. So whenever as we're talking about data transfer, we'll be talking about bits per second because of compression involved. A byte of data is compressed into bits of data. And when data transfer is involved, compression is a must. And that's why the basic unit of compression is, basic unit of data transfer is bits per second. Okay, data is stored in bytes, but when compressed, each byte may be compressed into fewer bits, of course. Compression is essential for data streaming, therefore it is referred to as bit streaming as opposed to byte streaming. So after compression, when you have, instead of a byte of data, you're left with a few bits of data. That's why when you stream that, it's referred to as bit streaming. Streaming media can be of the following types. The source of the website is a website. The user can download the media file and access it later at a convenient time. And that time, by convenient time, I mean that we're accessing information from our hard disk. The source of that data is our hard disk because I downloaded it. On the other hand, if I'm streaming the data, that means the source of the website, but the user may not want to wait for the file to be downloaded and can avail the on-demand streaming option. So I don't have the time to wait for the file to download. I just want to click on a button and I want to play it right then and there. In that case, what I'm doing is I'm doing on-demand streaming. Now, there are two types of streaming, by the way. There's on-demand and real-time streaming. YouTube, in which I access a video link, I simply click on the video and it starts playing back. That is on-demand streaming. By on-demand streaming, it means that the video is already stored in the server, and I'm simply posting a demand through my web browser to that web server, and that web server will return that video from its own local storage. So on-demand streaming requires that the video is stored on the server on its own, on the server, and I'm simply posting a demand and that video is being played back on my web browser. That's on-demand streaming. On the other hand, live streaming option means that the video is still being streamed. What that means is that the video is not locally stored in my hard disk. In fact, it's not locally stored on the server as well. So if I'm carrying out streaming, the server doesn't even have that video, and that content is being created as we view it. So for example, a football match, if I'm viewing that, it's a live football match and I'm viewing it over internet services on my web browser, that means currently I'm doing live streaming, and that content is being created as it's being streamed. Obviously, it will have lower quality because, of course, lots of connecting factors, and there has to be an uninterrupted supply of data. So therefore, if I reduce the number of bits by compressing more data, that means I will have lesser data transferred in the same amount of time, thereby reducing the need or the chances of data being, halting or lagging in between. But regardless of which, the data is being delivered to me in live streaming is being delivered to me as it is being created. And even the server that I'm accessing right now, even that server does not have the video on its own because it's happening as I'm viewing it on my screen. So that's live streaming. Okay, let's go back to on-demand streaming. On-demand streaming is two-step process. The first step is the media is buffered onto a location on the user's computer. Now, what does a buffer mean? We've studied the term buffer in so many contexts. In all contexts, the term buffer is involved. Say, for example, printer buffer. The term buffer is always used whenever I'm referring to a temporary storage device that is involved to store data for compensating the difference of data transfer rate between two communicating devices. So the printer buffer in this case, or in an example case, the printer buffer is used because the CPU is a very fast device and the printer is a very slow device. So if my CPU is waiting for the printer to print a page so that CPU can send another page, the CPU is wasting valuable time waiting on the printer, because printer compared to the CPU's time is very slow. And while the printer is printing a page, the CPU can be doing a lot of tasks. So what the CPU does is that it sends several pages to the buffer, and meanwhile the printer is printing its documents, taking its time. CPU does not have to wait, and it simply progresses towards other tasks. Now, again, we have two devices, the printer and the CPU, which have very different speeds of processing and doing work. And to accommodate this difference, we include this buffer in between, so that the printer, the slower device, can do its thing at its own rate, and my faster device does not have to wait for it. Similarly, if we look at the buffer here, we have the buffer here. Now think about it. Is accessing a video through your hard disk faster, or accessing a video through a server faster? Obviously, accessing a video through your hard disk is faster as compared to the server, because there are a lot of factors involved in the server, accessing a server. Your internet connection may be, variable. It may be slow, fast, whatever it is, and size of the video may be, very big, and the server must be busy as well. So a lot of factors that may, may affect the overall data transfer rate from the server. On the other hand, if I involve the buffer here, and this buffer, by the way, is in my user's computer, it's locally installed, I may be able to compensate the speed difference that is caused by the slow data transfer of a media server through your internet connection. So what happens here is that I allow for some sort of buffering, and that buffering takes place on my hard disk for media player to work. So what happens is that I access, for example, I'm accessing a YouTube video through my web browser. If I'm accessing, by the way, it says user computer, but let's focus on the web browser. Let's assume that this is my web browser. This web browser, through my web browser, I have sent a request to the media server to play back a video. The media server will start sending data to my computer, and my buffer will start filling up. Now, as you can see here, there are two watermarks here on my buffer, a low watermark and a high watermark. Basically, I am storing data in this buffer, and when I start playing that video in my video player, that data will be played back from this buffer, because accessing data from my hard disk, which is my which is where the buffer is stored, is faster compared to accessing data on a server. So basically, my media player is accessing that data through this buffer, which is located on my computer. Now imagine that if, for example, I start playing back data, the information from this buffer, as I consume it, will start deleting, and eventually the level of data will be dissipating from this buffer. I've started viewing the video, and it reaches to high watermark, then below that, and eventually starts going to the low watermark, so on and so forth. And if, say, for example, the buffer starts getting empty, my computer will send signals to the media server to send more data, because the buffer is now becoming empty, and the media server will replenish this buffer with more data, and it will do it in such a rate, it will attempt to do it in such a rate so that media player does not stop in any way. So the buffer is constantly kept at this portion, so that my media player has a constant uninterrupted video playback. Now imagine that I pause the video here, and I'm not consuming any more data. What that means is that if I have paused the video here, the media server continuously starts sending the data, and eventually my buffer will start filling up. It reaches the high water mark, and pretty much it exceeds the high water mark. Somehow it ends up here. Now, as soon as I pass the high water mark without consuming the data, my browser will send a signal, my computer will send a signal to the media server to stop the data flow. Because right now, my user is not consuming the data, so there's no need to send data here. And this media server can focus on other active users. My user is not currently using this data. So that's why whenever you pause a video on YouTube, you notice that the video pauses, and only for a few spaces ahead, the gray portion of downloaded video remains, but the whole video does not download. Only small portion, small part ahead the red marker exceeds to the gray part, only the small portion. Because the buffer, because it filled up, that red marker stays stop. I'm not playing any more video. The white underneath marker, which represents how much video has been downloaded, only a small bit protrudes behind that red line. That shows that the buffer is now full, and it does not exceed, that right mark does not reach the end of the marker on my YouTube video players. So what that means is that my buffer has reached the high water mark, and since I'm not consuming the data, the buffer is nearly full or possibly even full, because of which no more data is allowed here. And my computer sends a signal to the media server that my user is not currently consuming data. I have a lot of data in my buffer, so you can currently stop the data flow and take away the bandwidth that you've allocated me and give it to some other user who or other users, active users who are currently downloading and viewing the data as we speak. So when my user starts playing back the video, and say for example I come back and I start play back the video, now my data will be released from the buffer. My buffer will become emptier and emptier. Pretty soon it will reach the low water mark, and when it reaches the low water mark, my computer will send a signal back to the media server. Okay, now please restart sending data, because now my user is actually starting to reconsume the data, so I will need the buffer replenished again. So then the media server will start sending data again to this buffer. So basically this high watermark or low watermark in a buffer ensures that my media server does not continuously send data when I don't need it at the moment. And if I don't need it at the moment, the media server will stop sending data to me. And since all servers are time shared, it will take the time that it was giving to me and give it to some other device or shared among other devices, thereby increasing their download speeds. And it's a fair method, by the way. So because it avoids this possibility that I pause the video and I download the entire video and I don't even watch it and I turn the computer off. So my media server downloaded an entire video on the buffer, and it sacrificed bandwidth from other active users to give me time to download video, and I didn't even watch the video. So to avoid that situation, we have introduced this buffer here, so that if the buffer becomes full, that means I'm not consuming the data, or possibly that I'm not consuming it at the same rate as it's being downloaded. So that way my media server can be alerted and data transfer can be halted or slowed down for some time. So if the buffer starts reaching low water mark, that means that the data transfer inflow of data is slower than my consumption rate, in which case my server will actually send a request to the media server to send data or resume the data flow. In that case, my buffer will start becoming replenished again, and my media player will possibly not lag in any way. So this is how my media streaming, on-demand media streaming, is carried out. Okay, now let's look at the concept of media streaming with broadband link. For media streaming, a broadband link of at least 2.5 megabits. So how do I know it's a megabits? Because if it's written with a small b, it's megabits. If it's written with a capital B, it's megabytes. So just if it's written in abbreviation, you should be able to understand that small b means bits, capital B means bytes. So for media streaming, a broadband link for at least 2.5 megabits per second is essential for good quality movie presentation. However, such bits may not always be available. Therefore, servers should hold videos with varying compression rates to accommodate for different user requirements. You may have noticed that you started viewing a YouTube video at 1080p, and all of a sudden the video resolution changed automatically and dropped down to say 240 or 144p. And you can see a noticeable difference in the video. It's more pixelated and quality is suffered in a way. It lacks the details that it did before. What happened here is that my video resolution has reduced. And why it has reduced? It's not actually reduced, but my YouTube, for example, YouTube is playing back a video, a lower quality video. Why? Because my data transfer rate, my bit rate has reduced. Now I'm spending 3 minutes to view a video. time will not remain the same, because if I start lagging, that 3-minute video will go to say 3.4 or 4 minutes, for example. It may take longer than 4 minutes because there is lagging. Now what we can do is that you have 3 minutes. I'm not going to change the time, but since the bit rates, bits per second have reduced, and I'm not altering the time, what I can do is that I can reduce the number of bits that I'm transferring you per second. So basically, how I'm going to manage this is by keeping the time constant. I can change the number of bits being transferred to you. I can reduce the number of bits being transferred to you. So, and how that happens is because how that can be seen in front of you is by reducing this image resolution, and if the video resolution, and because the video resolution has reduced, that means the overall quality has reduced, and of course the size of the video has also been reduced. So the time is kept constant. I'm not allowing more than 3 minutes to play for this video. This video is 3 minutes long. I will only spend 3 minutes. There should be no lagging whatsoever. So what I can do is I can reduce the size of data. So the bit rate has reduced. The seconds are the same, but the bits per second reduces. So that's why, without lagging, if you want to avoid lagging, if YouTube wants to avoid lagging in any way, it will reduce the size of the video so that less number of bits are being transferred per second, and there is no lagging. The time stays the same, but the number of bits being transferred to you per second reduces. So this is the concept behind bit streaming, and I hope it's a little cleared now, and we will be talking more about this in later sections. But following bit streaming, a very important topic regarding internet comes IP addressing, and we'll be looking into that in the subsequent lectures. So thank you, take care.